Okay, we're back. We're going to look at a couple more cases of using the law of sines. This case is the side-side angle case. This is the one, if you reverse those letters, the one that your geometry teacher told you to avoid when you were trying to prove things in geometry, and you'll see why in the next two cases, because it can cause some trouble. So let's take a look at this. We have a triangle ABC with alpha being 67 degrees, side A being 100 units, and C being 125 units. So if I have some sort of, I don't know, oblique triangle, and I label it A, B, C, alpha is 67 degrees, side A is 100, and side C is 125. So I've got to figure out two angles, the measurement beta, the measurement gamma, and one side, the side length B. Now, using the law of sines is all about finding one full ratio that I can work with, meaning I need to have one side and its opposite angle. And in this particular case, that's going to be alpha and A. I have alpha and A directly across from each other. So that's going to be the complete ratio I start with. Sine 67 degrees over 100 equals. Now, the second ratio I use, whether it's sine beta over B or sine gamma over C, I need to know one of those values. When I'm solving a proportion, there's four parts to it, two numerators, two denominators. I need to know 3 out of the 4 parts so that I can solve the proportion. Now, in this particular case, the only other value I have is side C. And that tells me I'm going to use the ratio sine gamma over 125. Now, since I'm going to solve for gamma, I'm probably going to have to use an inverse trig function at some point to solve this. But before I get there, a little bit of algebra that 125 sine of 67 degrees equals 100 sine gamma, so that sine of gamma equals 125 sine 67 degrees over 100. And so that's what I have there. I could go ahead and simplify the right side right now, get a decimal approximation, or I could go straight into the inverse trig function. I think I'm going to go to the inverse trig function and leave the right side as is, so I don't have a decimal approximation, but I have an exact value. So I'm going to rewrite this as the inverse sine of, and this is going to be 125 sine 67 degrees over 100 equals gamma. Remember that inverse trig functions are going to input the ratio and output the angle. So it looks really bad, but really and truly we're going to go ahead and use our calculators to find the value of gamma. So we'll take a moment, make sure your calculators are in degree mode, and put that in there, and we'll get that answer in a moment. And hopefully you paused the video, you did that, and when you do that, you get an error, and you get a domain error. And what that tells us is this is something we can't do. You didn't make a mistake putting that in there. So why don't we take a look at that? Let's take a step back and look at why we ended up with that error. If we go ahead and instead of writing sine of gamma using the inverse trig function, let's leave it as is, sine of gamma, and go ahead and evaluate this right side of the equation. Put it into your calculator, get a decimal approximation, and let's see what that is. So go ahead, pause the video, put that in the calculator, get an answer there, and see what it is. All right, so hopefully you paused it, you're back, and when you did that, you ended up with a value of about 1.15 something or other. But when I look at this, this can't happen. The range of the sine function is between -1 and 1. Getting an output of 1.5, this value is outside the range of the sine function. which means there is no angle gamma. It doesn't exist. There is no angle that you could put into the sine function that would give you 1.15. So what is the implication of that? Well, that means this setup that we were given, the setup that we were given for this triangle, right there, that setup is impossible. You cannot construct a triangle with an angle of 67 degrees, the opposite side being 100 units, and another one of the sides being 125. It's impossible. So that's one of the reasons why in geometry you could not use that case which you spell those letters backwards. All right? So that's one possibility for the side-side angle case. All right, we're going to pause this video. We're going to come back with another case of it as well.